Let's talk about database models. A database model is simply a framework that explains how a database works. It has three main parts. First, the data structures. These show how information is organized. Second, the operations. These are the actions we use to work with the data. Third, the rules. These make sure the data is valid and correct. Some database models are officially described in books and standards. Others come from popular database systems that people use in practice. One of the most important models is the relational model. It was introduced in 1970 by E.F. Codd at IBM. By the 1980s, it was used in commercial products. The relational model organizes data in tables, and its rules and operations are standardized in SQL, which is the common language for relational databases. Before relational databases, in the 1960s and 1970s, hierarchical and network databases were popular. Computers were slow and memory was small, so these systems were built mainly for speed. But they were not very simple or flexible. As computers improved in the 1980s, relational databases became easier to manage and quickly replaced those older systems. Relational databases were first used for transactional data, things like bank records or airline bookings. But when the internet grew in the 1990s, we entered the age of big data. Suddenly, we had huge amounts of information and data structures that changed very quickly. This led to new types of databases after 2000, designed especially for big data. Even so, relational databases did not disappear. They have been updated to handle big data better, and they still dominate the commercial database market today. So the story of database models is really a story of progress, moving from performance-focused systems to relational simplicity, and now to handling the challenges of big data. All right, team, let's stretch our minds with a quick database warm-up. No pressure. Just think it through and trust your instincts. First question. Which of these is a relational database? Is it Oracle Database, IDMS, or MongoDB? Take a moment. Think about which one uses tables and SQL. Got it? Great. Second question. The relational model, when it was first developed, was designed for what kind of applications? Was it for big data analysis, transactional systems like banking and airline reservations, or small desktop databases? Picture the 1970s. What kind of data needed structure and reliability? Third and final brain teaser. Back in the early 1980s, what was the main challenge that slowed down the commercial use of relational databases? Was it reliability, processing speed, or cost? Think about the tech back then. Slow machines, limited memory. What would have held things back? Well done. Whether you nailed all three or sparked a new question, you've just activated your database brain. Let's keep that energy flowing as we dive deeper into today's session. Let's begin with the foundation of relational databases, the relational data structure. This structure is built on the principles of set theory, which gives us a mathematical way to organize and reason about data. In set theory, a set is an unordered collection of elements. For example, ABC is the same as CBA, because order doesn't matter. A tuple, on the other hand, is ordered, so ABC is different from CBA. This distinction between sets and tuples is crucial in understanding how relational databases work. In relational databases, data is organized into tables. Each table has a name, a fixed set of columns, and a varying set of rows. Think of it as a grid, where the structure is stable, but the content can change. Each column in a table has two defining features, a name and a data type. The name identifies the column, while the data type specifies what kind of values can be stored there. A row is essentially an unnamed tuple of values. Each value in the row corresponds to a column, and it must match the column's data type. This is how relational databases ensure consistency. A data type is simply a named set of values. When we define a column, we are saying, this column will only accept values from this set. For example, a column defined as integer will only accept whole numbers. Finally, here's the key principle. A table is a set of rows, and since sets have no inherent order, the rows in a table are not stored in any particular sequence. If you want order, you must explicitly request it in your query. Now, let's work on this activity to help us understand commonly used terms in data processing. Next, let's look into this table to understand data structure terms. Take a moment, pause the video, and work on this activity to test your understanding. Now, take time and understand why you excelled or why you missed out on some questions. Congratulations, you have just rewired your brain for database systems.